In this demonstration, we are going to deploy a distributed edge application spanning multiple operation systems. To the right, we have Kubernetes, and to the left, we have an ECU running on Flatcar OS, and we have a Windows gateway, and we have an XP board running on ThreadX. And my application is comprised of multiple components. For Kubernetes, I want to deploy a pod, and for the Flatcar system, I want to deploy a WebAssembly module and the eBPF module. And for the Windows gateway, I want to deploy a Windows application. And for the NXP board, I want to flash a binary. In the software-defined vehicle scenario, you can imagine the Kubernetes cluster is the HPC cluster, the Flatcar is the ECU, and the gateway is the infotainment system, and the NXP board is the sensor. It's really hard to manage this kind of application because each of the artifacts comes with their own toolchains. For instance, you use the Kubernetes API to deploy the pods, and you use shell scripts to deploy the WebAssembly module or eBPF module. And you can leverage Windows SDK to deploy the UWP application, and you can use PowerShell to drive a script that flashes the drive through a USB cable. The challenge is how to orchestrate these toolchains so that you can treat all those components as one unified application. This is where Symfony comes in. Let's say we install Symfony control plane on the Kubernetes cluster. We can use Symfony native Kubernetes provider to talk to the Kubernetes API to deploy the pod, no problem. And for the ECUs, Symfony offers a lightweight agent called Piccolo. It can drive shell scripts to deploy those modules. And the way the Piccolo communicates with the control plane is to use an outbound HTTPS connection only. So in this case, the Symfony control plane will stage the desired state on the control plane itself, and Piccolo will pick it up from the control plane. And the Windows box is a more powerful box, so you can deploy the complete Symfony agent on it. And we can load different providers into the agent. For instance, we can use the Windows 10 set load provider to use Windows SDK to deploy the Windows application. Of course, we can use other providers. For instance, we can make a Chocolatey provider or a Winget provider in the future. And we can use the script provider to drive PowerShell script that will flash a binary onto the XP board. And the way these providers communicate with the control plane is either through HTTP or MQTT. In this case, I'm going to use an MQTT broker. So in this case, the Symfony control plane will use a proxy provider that will communicate the desired state and the current state through the MQTT broker with the providers. And the three boxes to the left represents the flexible deployment topology we offer for Tiny Edge. For ECU device, we have a lightweight agent, which is 4 megabytes. And if you opt out HTTPS for a trusted subsystem, it's 2 megabytes. And for the gateway, you can deploy a complete agent, which is about 97 megabytes for Linux and 80 megabytes for Windows. And on the NXP board, we support agentless deployment. So in this case, there's no agent on the board. We're just using a remote interface to manage the board. And you can see Symfony can orchestrate those toolchains and complex topologies into one unified workflow. And this enables Symfony to bring values such as approval process through a logic app. You can run a logic app approval process to send an email to approver and schedule a maintenance window. So everything is installed during that maintenance window in a specific order. And because Symfony works natively on Kubernetes, you can also interact with Symfony through Kubernetes API using kubectl, Helm, Arc, GitOps, the standard toolchain. And with ARM binding, you can operate the Symfony object through ARM radius as well. So that's the scenario we want to deploy today. Let's look at the solution definition. Here in Visual Studio Code, you can see the Symfony solution definition. This solution contains 4 components. I have a container, I have a Windows UWP application, I have a WebAssembly module, and I have a binary file. And each component has these constraints. Basically, the constraint saying the container needs to go to Kubernetes, the UWP application needs to go to a PC, the WebAssembly needs to go to the ECU, and the binary needs to go to the RTOS system. Let's see how we deploy it. But before we do that, let's first check the status of the 4 machines. Let's start with the Kubernetes cluster. Here is my Kubernetes cluster. I already have Symfony deployed. If I do kubectl get pods, you can see a whole bunch of Symfony pods as well as Mosquito message broker on the cluster, but there's no user payload yet, right? It's just Mosquito and a bunch of Symfony pods. And I already have the targets registered. If I do kubectl get targets, you can see I have the 4 targets defined. Like I mentioned, Symfony works natively on Kubernetes, so you can operate Symfony through kubectl. But of course, you can use the REST API if you choose to as well. And I also have the solution defined. This is the solution you just saw in Visual Studio. So this is the current status of the Kubernetes machine. There's no user pods running on the machine yet. Now let's look at the NXP board. So I've connected to the board using PuTTY, and you can see the board currently is running a default Hello World application, and nothing else is going on. Now let's look at the Flatcar machine. This is the Flatcar machine, and if you do systemctl status piccolo, you can see the piccolo agent is running. The piccolo agent is bootstrapped by the Flatcar ignition mechanism, so it's out of box available in this case. I'm going to quit this and clear. So that's the agent. And the idea is to deploy a website contained in a WebAssembly onto this Flatcar device. And if I go to the website now, you can see the page cannot be reached because there's nothing deployed yet. So that's the Flatcar machine. And the last one is the Windows machine itself. So the Windows application we want to deploy on this PC. The app is called Home Hub, but if I do a search for Home Hub, you can see there's no such application installed on this machine. Okay, so that's the 4 machines we've all checked. Now let's do the deployment. So I'm back to my cluster. I will do kubectl apply instance. So now I'm going to create the instance. I will go back to observe the PuTTY console first. Now we are just waiting the deployment to happen. And now the board has been flashed and restarted. And if I move the accelerators, you can see the board is working properly. So that's the XP board got flashed correctly. Now let's look at if the Windows application is installed. If I do a search for Home Hub, you can see indeed the application has been installed. And if I bring it to the correct window, you can see that the UI is running. And let's look at the Kubernetes machine. Back to the Kubernetes cluster, if we do kubectl get pod, you can see this multi-OS instance has been created. So the Kubernetes deployment has been finished as well. The last machine to check is the Flatcar device. Remember, we are hosting a website in the WebAssembly on the Flatcar. So if I go to the browser, we should see the website. If I do a refresh, indeed, we have the web server running on the WebAssembly deployed to the Flatcar. One thing I didn't mention is that in this deployment, my Kubernetes cluster is actually an AKS cluster running on cloud. So I'm able to control this distributed deployment on my edge environment, on my PC, on my local USB attached devices and on my local Flatcar virtual machines, all the way from cloud. And now let's remove this. If I do kubectl get instance, you can see this instance is currently deployed. It has 4 targets and deployed to all 4 targets. Now let's delete this. Delete instance. Okay. Now the Windows application is still here, and the PuTTY console is still here. Let me just put the 2 windows side by side. You can see what happens. So now you can see the board has been reset. It's reverted back to the original Hello World application, and the Windows application has been shut down and removed from this machine. And if you look at the pods on the machine, you can see the user pods has been removed. And if we go to the website and do a refresh, the website is gone. This is it. We just deployed a distributed application spanning 4 operation systems from cloud to a distributed edge. Thank you.